Hi class, welcome back to office hours for today, the week of April 15th, 2022. I know that exams are coming up, so I'd like to take today's time to review some concepts that we haven't covered in a while, like probability, expected values, and of course, linearity of expectations. So let's take a moment to review. The expected value of the sum of random variables is the sum of their expectations. But what does that mean, right? Like, in its essence, it essentially says the expected value of an array of events, right, is equal to the sum of each individual event's expected value. So, for example, for a dice, right, you have 6 events possible, 1, 2, 3, 4, 5, 6, each with the probability of 1, 6 occurring. So your expected value is equal to 1, 6 times 1 plus 2 plus 3 plus 4 plus 5 plus 6 equals 3.5. And this is because of the fact that we added up the expected value of getting a 1, the expected value of getting a 2, the expected value of getting a 3, so on and so forth to get 3.5. So how do we apply it in this problem? So Tom is lost in the GGBL after an exam and is trying to get out. There's 4 identical hallways leading away from him. One of the hallways will take 12 minutes to walk and will lead him out. However, the other 3 hallways will take 10 minutes, 10 minutes, and 40 minutes respectively to walk. After the end of these 3 hallways, Tom falls through a trap to go back to where he started. And we can assume that Tom can choose only one hallway at a time and can't turn around. When Tom falls through a trap door, he can't tell which hallway he chose last, so each choice is independent. And the hallways are indistinguishable aside from their outcome. And so T is a random variable for how long it'll take Tom to escape, and what is the expected value of T? So let's take some notes first. So hallway 1, right, takes 12 minutes and leads him out directly. So the probability of choosing hallway 1 is 1/4. And if I do choose hallway 1, it just takes me 12 minutes to leave the building. What about hallway 2? Well, hallway 2 takes 10 minutes, but I go right back to where I started. So it's 10 minutes, 1/4. But because I go right back to where I started, it takes another E of T, so the expected value of T minutes to escape the facility. So it's just 10 plus the expected value of T, since I'm essentially taking 10 minutes to do absolutely nothing and going back to where I started. And the same goes for hallway number 3, since hallway 3 is 10 minutes as well and leads right back to where I started. And it also has a probability of 1/4 occurring. And for hallway 4, it takes me 40 minutes to go right back to where I started. So that's just 40 plus E of T with a probability of 1/4 chance occurring. So we can apply linearity of expectations here because we have an array of events, right? And so the array of events is just the expected value of each event and then summarized to get the final expected value of how long it'll take for Tom to leave. So what is 12 times 14? Well, 12 times 14 is just 3. And then 1/4, 10 plus E of T for number 2. And since 2 and 3 are the same, we can multiply this by 2. So we get 2/4 times 10 plus E of T for the expected value of 2 and 3. And for number 4, so hallway 4, it's 10 plus 1/4 E of T. And so we can sum these values together to get 3 plus 1/2 times 10, which is just 5, plus 1/2 times E of T, which is just 1/2 E of T, plus 10 plus 1/4 E of T equals, and we put equals E of T because the summation of all these values occurring is equal to the expected value of time in general that Tom takes to escape the building. So we get 18 plus 3/4 E of T equals E of T. And thus, E of t equals, or 1/4 E of t equals 18. So E of t equals 72. So the expected value for Tom to escape the GGBL is 72 minutes.